Okay, just a few more examples on differentiating trig functions, just some harder examples. So we need to be very, very careful with ones like this. So this is the derivative of the sine of 1 on x. Now 1 on x means x, the x itself is to the power of -1. So it's only the x that is to the power of -1. It is not like the questions that we were just doing in class. So sine of x to the -1, where the x is to the -1, does not equal sine of x to the -1. It is not, they are not the same. Okay, because with this, that one is 1 on sine x. So sine of 1 on x, you can clearly see, is not the same as 1 over the sine of x. So please be very, very careful if you're going to differentiate something that looks like this. So to differentiate the sine of 1 on x can be written as x to the -1. So now the derivative of that, okay, so this is what we're differentiating. We don't bring any -1 down to the front like we would have done here. Okay, it's just differentiating the sine of this function is cos of that function times the derivative of 1 on x. Now, I need to differentiate x to the -1. So if y is x to the -1, that's the same as 1 on x. I need to differentiate 1 on x. So the derivative of that, so to differentiate 1 on x, it needs to be written as x to the -1. We bring the -1 forward, we write the x out, we drop the power by 1, and to rewrite that, you get -1 over x squared. So differentiate sine of x to the -1, it's cos of x to the -1, times the derivative of x to the -1, which is -1 over x squared. You have to be really, really careful with this. Now, how do we write that? That is the same as writing, now cos of x to the -1 is 1 on x. So it's the same as writing cos of 1 on x times -1 on x squared. So what is on the numerator is the cos of 1 on x is on the numerator. And what is on the denominator? So the numerator is cos of 1 on x times -1. So it's negative cos of 1 on x. And on the denominator, I've got x squared. Okay, so just be really, really careful with that. Okay, now here is another example here. Differentiate this. So differentiate y equals sine of root x. Okay, so again, we need to change the way that this root x looks, and it's sine of x to the power of 1/2. So only the x is to the power of 1/2. Now this is not the same as doing this. They're different. So this is the sine of the square root of x. It is not the same as the square root of sine x. Now, we did do something like that in our last video. So please be careful. These are not the same. So this one here is sine of x to the 1/2, whereas this one is sine x all to the power of 1/2. So they are not equal. You have to be really careful when doing these. So again, I'm differentiating the sine of this function. So to differentiate sine, we write cos of that function times the derivative of the x to the 1/2. Now, the derivative of x to the 1/2 is bringing the 1/2 to the front, write out the x, drop the power by 1. Okay? Now, just be careful here. I've got cos of x to the 1/2 on the numerator. I've got, well, 1/2 times that, so 1/2 is there. And this is x to the -1/2, which is really x to the 1/2 on the denominator. Okay? So just looking at that, 1/2 x to the -1/2 is the same as 1/2 times negative powers means 1 over. So what I've got is 1 on the numerator and 2 times x to the 1/2 on the denominator. So let's now write those powers of 1/2 the way that the question was written, which is with square root signs. So this is the cos of the square root of x over 2. X to the 1/2 is the square root of x. Another harder example, differentiate the following. If y equals the square root of cos of 2x minus 1. Now you need to rewrite that before you start. Now all of that is the being square rooted, so all of that is to the power of a half. So you have to rewrite it as y equals, in brackets, cos of 2x minus 1, all to the power of a half. Now that it's in a format that we can differentiate it, because it needs to be in some function of x to the power of n, okay? Because the rule on your formula sheet is this, function of x to the power of n, the derivative of that is bring the n to the front, write the function out, drop the power by 1 times the derivative. Okay, that's what you'll see on your formula sheet. Okay, so now it is a function of x to the power of n. So let's bring our power to the front, write out our function, drop the power by 1 times the derivative. So this is what I've done. I've done the n, function of x to the n minus 1 times, now differentiate what's inside. Now I have to differentiate cos of 2x minus 1. Now if you differentiate cos, you get negative sine 2x, but to differentiate cos 2x, it's negative sine 2x times the derivative of 2x, which is 2, and if you differentiate a negative 1, you get 0. So I'll write minus 0 or plus 0, it wouldn't matter. Okay, so I actually don't need that. So what I've got is 1/2. Now this is to a, actually, before I do that, I've got 1/2 times 2. So 1/2 times 2, that's 1. I've still got a negative, and I've got sine 2x on the numerator, okay? And this is on the denominator, because it's a negative power. So I've got cos of 2x minus 1 to the power of 1/2 on the denominator. So again, this negative power belongs on the denominator, so I can put that down there. And then on my numerator, I've got 1/2 of 2 is 1, but I've got a negative. So it's negative 1 sine 2x. So we've got negative sine 2x over, now the question was written with square root, so the answer should be written with square root. So this will be over the square root of cos of 2x minus 1, because that's to the power of 1/2. Here's a question from the exercise. It's question 7E. Now be careful with this. This is not product rule. This is not this. So don't think that this is sin x times cos x. It is not. Okay? This is the sine of cos x. Okay? So this in here is your function of x. So it is not this. It is not this. So don't think I'm going to use the product rule here. You're not. It's the sine of this function. So it is not the same as sin x times cos x. That's different. For this, you would use product rule. Okay? And I think you've already done that earlier in your exercise. So you do not do this. So what I've got is the derivative of sine is cos. So the derivative is the cos of this function. So it's the cos of x. Okay? So this is sine of function of x. The derivative is cos of that function times the derivative of the function. So the derivative, so if I say my function of x is cos x, f dashed x is negative sine x. That's the derivative of cos x. So sine of function of x is cos of function of x times f dashed x. The derivative of cos x is negative sine x. Now, this is not, please, this is not cos squared x, because this is not, so it's not cos x times cos x. It is not that. Okay? So that is not cos x times cos x. So please don't write cos squared x. It is the cos of the cos of x. So that does not equal, cos x. They are different. Okay? So cos x times cos x does not equal cos of cos x. So cos squared x does not equal cos of cos x. So please don't write that as your answer. So what you've got, I'll just put this negative sine x first. So what my answer for the derivative is negative sine x times the cos of x. Okay? Now look, these are very tricky. Okay? You really have to look at it as sine of my function. Okay? Is cos of my function times the derivative of that function. Okay, so this is cos of my function, and this is my derivative of that function. Okay, so just Please be careful with that. You will be doing a very similar one as well. Just another example, differentiate something like cos of pi minus 2x. Okay, so something like that. So again, if you differentiate cos, you should be fine with this one. Differentiate cos, actually, I'll make this pi minus x. All right, pi minus x. So differentiate cos of pi minus x. Look, we could do this a few different ways. I'm going to show you 2 ways to do this, okay? Okay, so the first way would be just to apply the normal rule. So differentiate cos, you get negative sine of pi minus x times the derivative of pi minus x. Now pi is a number, you differentiate that, you get 0, and differentiate negative x, you get negative 1. So I end up with negative times negative, I get positive sine of pi minus x. That's one way to do it. The other way you could do it is simplify cos of pi minus x first. Now when you look at that, pi minus x, cos of pi minus x, that's telling me quadrant 2, you know, pi minus x is a quadrant 2 result, okay? So there you could actually get another answer. You could do this another way. The cos of pi minus x is the same as the acute angle is cos of x, but because it's quadrant 2, remember pi is 180, this is cos of 180 minus, it's like this, theta, quadrant 2 is 180 minus theta, etc. Quadrant 3 is 180 plus theta, or pi plus. Quadrant 4 is 360 minus, or 2 pi minus. So cos of 180 minus x is the same as negative cos x, because remember with all stations to central, cos is negative in quadrant 2. So it is actually the same as differentiating negative cos x. Now be careful, you get negative. Now the derivative of cos of x is negative sine x. So I've got negative, and then I differentiate cos, and I get negative sine x, which is negative is positive sine x. But why don't I have that answer here? The reason I don't is because sine of pi minus x, again, quadrant 2, is pi minus. That is the same, actually, as sine of x, because in quadrant 2, the acute angle here is x, and with all stations to central, sine is positive as well in quadrant 2. So the actual answer for the derivative is sine of x. That's actually the simplest answer, okay? So you could use either method, that's fine, all right? So you could rewrite what cos of pi minus x is in terms of acute angle in whichever quadrant it falls in, and then do the derivative, or you can just use the rule to differentiate, and then simplify at the end if you recognize the simplification. And just another one here, you should be fine with this one. Differentiate cos squared x minus sine squared x. Now remember that is cos of x squared minus the sine of x squared. So change the way it looks before you differentiate it. So the derivative will be, remember, bring the 2 to the front, write the cos of x out, drop the power by 1, times the derivative of cos x, which is negative sine x, right? So that one's done. Take away this derivative. So bring the 2 to the front, write the sine x down, drop the power by 1, times the derivative of sine x is cos x. So therefore you've got, now just be careful here, you've got 2 times negative sine x cos x, so it's 2, negative 2 cos x sine x minus 2 sine x cos x, or cos x sine x, it's the same. So sine x cos x is the same, as cos x sine x. The reason I've swapped them around is you can see they're like terms, so just be careful. I've got negative 2 cos x sine x minus 2 cos x sine x. I've got minus 4 cos x sine x. Often you see sine written before cos, but it doesn't matter. Either one's fine. Okay?